What is the number one most costly thing that you can do with your engineers if you're in product management? Or frankly, if you're an engineering leader, what's the most costly thing that you can do with your engineering team? We're going to talk about that today, and we're going to dispel some common myths that people spread pretty widely around tech around what is the most expensive or costly thing that you can do that wastes engineering team time and talent. Number one, that we're going through the myths first. We'll get to the thing that is the actual cost at the end. So the first myth, it's incorrect to say that building and releasing an imperfect version of your product is the most costly mistake that you can make with your engineering team. That's just not true. And part of the reason why that's not true is that oftentimes you want to be deliberately imperfect so that you can trade off and get to market faster. So there's that whole conversation around what a minimum viable product looks like and how minimum is too minimum. I'm not going to get into that whole discussion today, but I did want to call out, if you're thinking about the highest and best use for your engineering team, you want to be thinking about product in terms of an elastic time constraint so that you can say this is the correct amount of time to spend on this product for the risk and the reward that we're looking at. And that can include shipping imperfect product. That's not necessarily a waste of your engineering team's time. And if you hear otherwise, that's a myth. It's myth number one. Myth number two is the opposite. It's a too perfect version. And I do hear people who love the idea of an MVP saying that the worst thing you can do with your engineering team is to spend too much time on the product and to make it too perfect and too polished. I don't think that's always true. I think it's sometimes true. Just like a lot of things in product, it depends on the context. For example, if you're trying to solve a problem that needs to be all the way solved before it's solved at all, you're going to need to polish the edges. A great example of that is the iPhone was released in a fairly polished state, even in version 1. And I know we look back on that now from the perspective of like our iPhone 15 over here, or whatever it is, and we say, I cannot even imagine being in 2007 and calling that phone polished. But at the time, it was polished. I'll give you a different example that's not Apple. If you are trying to solve the problem of drone delivery, I heard a good talk on this actually when I was at Amazon. You need to be sure that your drones will never, ever, ever fall out of the sky, because the cost of that would be killing a customer. And that's way too expensive. You can't ever afford that. That's never acceptable. And so you have to solve the problem of safe flight and safe package delivery completely before you release it all. And so it would be incorrect in that context to say you're wasting your energy by spending too much time perfecting the product, because you're not wasting it, because that's the bar the product demands. I'm going to make a second point, though, here that is rarely made and that I want to stand behind. It is also true that the most wasteful thing you can do with your engineering team is not to over-perfect a product that you could have released sooner. That's still not a great thing to do. So if you are in a world where you can release a scrappy minimum viable product, and those things do exist, not everything is high stakes like drone delivery, great. Maybe you're releasing a sort of a small proof of concept piece of software, and maybe you spent too much time on it with your engineers. That's not a great choice. It's still not your worst choice. And we're here today looking for your worst choice as an engineering manager or engineering leader, because I think understanding that helps you understand where you can put your time most. And this goes for product too. Okay, so if you spend your time on creating imperfect versions of things, that's not the worst thing you can do. If you spend your time creating too perfect versions of things, that's myth number two, that's still not the worst thing you can do. And the reason why is neither of those things play with the core risk factor involved. Those are all playing with engineering time as the key risk factor, and that is a false assumption of risk. Your biggest expense here is not the cost of your engineers. And people assume it is. And so when they talk about you built it too imperfectly, now the engineers will have to go back and do it again, it still translates to engineering time as the basic unit of economics. If it's too perfect, it goes back to engineering time as the basic unit of economics. It's based on a flawed assumption, because at the end of the day, engineering cost is not the biggest risk factor for your business. And I'm going to give you one more example on the engineering cost fallacy. So the third one that people often do is they say engineers need to maximize the time they spend on keyboard and not planning and thinking, right? There's this assumption if the engineers aren't producing code, they're not doing work. And anyone who's worked in engineering will tell you that that doesn't make any sense at all. But business leaders sometimes make that assumption. And sadly, product managers will sometimes go along with. That is absolutely not a mistake, a problem, something that needs to be corrected. Engineering thinking and planning before they go into coding is actually a great choice. And so this is one of those things where there's not really, in my mind, much of a debate. You want to make sure you have time for your engineers to think and plan carefully. But people do, because they think of engineering cost as time it takes to produce lines of code, assume that you have to have your engineers sort of maximizing the number of lines of code that they output. And any engineer will tell you it's actually not the number of lines that you want to maximize, it's the efficiency and elegance of the system and the way it's able to solve the problem. And so we have this factory production mindset that has crept in from, frankly, the 19th century and the early 20th century when we did assembly lines, where we assume that engineers are workers on assembly lines mentally, and therefore they need to be working to make code all the time. And the core cost that we're dealing with is like, how quickly can they turn out the code, and is the code the right quality? And that factory mindset underlies all three of these. That's what we talk about and think about when we say this time unit cost of engineering as our biggest risk factor. I want you to take that whole mental model and just put it to the side. It's not super helpful in actually understanding the real cost, because at the end of the day, that is the wrong mental model to understand software. Software is not a factory. You do not make software on an assembly line like that. Instead, software is a series of bets that you're playing on how you can assess product market fit using software. And if you get the bet right, software gives you tremendous leverage to unlock that value farther. And that's why software isn't like factories, because it's not like you're making 5 different kinds of cars and you can make 1,000 of them cheaply as soon as you get one to work. You're actually committing to a production run and you're making them linearly when you're dealing with physical goods and physical products. I've had to do that. But with software, it's actually really elegant and really easy to make these theses or bets and see if they fit. And that brings me to the part that is the biggest cost. What is the biggest cost for your engineering team in a world where you actually understand how software is made and the unit economics of software? It's aiming incorrectly. It is producing bad theses or bad bets that you will then follow up and have to spend time on when you shouldn't be spending time on the bet in the first place. And that is why product is such a high leverage hire. Because at the end of the day, a product manager's job is not to make bad bets. They need to make bets that are as high quality as possible. That doesn't mean you expect every single one of them to work, but it does mean that you expect them to be in a direction of a learning loop, really deliberate, as high quality as possible, grounded in customer as much as possible, and that you expect the product manager to be able to learn and adapt quickly. And so when you're hiring for PMs, that's what you're looking for. And when you're looking at the cost to your engineering team, you're looking to basically say, is the engineering team spending their time on the right bets? And so in a sense, the value of the engineering team is contingent on the value of product direction. And whether or not you get your product direction from a product manager or from an engineering leader or from your CEO, that's still the fundamental question. Are you putting your engineering team against the right bets? Because each bet you start is like a little thread across an unknown landscape. And if you start that thread, just the motion of momentum tends to carry you forward on that thread. And you will put inordinate effort into trying to prove out that thread going forward. It will take you longer than you expect to stop, longer than you expect to release fast follow features. That's just the way software works. So you better get where you want to start right. And that's the key risk. If you are bad at picking where you want to start at exploring what I would call a latent space for product, where you're trying to figure out whether the product fits or not, if you pick incorrectly, if you frame the problem wrong, if you pick the choice of features for your MVP set so you're not actually learning something, that's going to be a problem. That's a bet that you can't take back very easily. That's something that's going to be very expensive because your entire effort from your engineering team would be poorly invested and poorly chosen from day one. Like, it doesn't even matter if it kind of works. If you frame the problem badly enough, it won't be scalable. In a sense, it is possible to get your engineering team going in a direction where it will take months to unwind whatever you do. You will learn nothing and your bet will be wrong from the get-go. And I have seen that happen. And that That is the actual risk of how you waste time with engineers. And it's not just product managers that do that. I've seen business leadership do that. Sometimes I've seen engineering leaders do it. And if you understand how software works, getting your engineers focused on the wrong bets is the number one biggest risk you can face. So make sure that you are betting correctly. And that is probably a separate video. We'll do a separate conversation on how you aim or how you set up your bets correctly. But I wanted to call out those myths because a lot of people think, oh, it's about over perfecting your product. That's the most expensive thing you can do with engineers. No, it's about under perfecting the product. You're releasing a flawed product. That's the most expensive thing you can do because you'll have to rework. Again, no, unit cost is not the problem. And unit cost is also not the problem when your engineers take time to think, which is the third major myth. None of those are really the issue because factory models of production for software are a flawed mental model. Software is about bets, and the core value that you have is making the right bet, and it follows that the core risk that you take is making the wrong bet. That is the most expensive thing you can do with your engineering team, and I recommend not doing it. Let me know if you have any bad bets or good bets that you want to chat about in the comments. Cheers.